Hello friends, welcome back to the series. Today let us explore what is artificial intelligence. Artificial intelligence is the simulation of human intelligence processes by machines, particularly computer systems, enabling them to perform tasks such as learning, reasoning and problem solving. Next, what are intelligent agents? Intelligent agents are autonomous entities that perceive their environment, reason about it, and take actions to achieve specific goals or objectives. Now, in this artificial intelligence, what is uninformed search strategies? Uninformed search strategies are algorithms that explore the search space without any domain specific knowledge, relying solely on the information available in the program definition to find a solution. Now, what is breadth first search? Breadth first search is an uninformed search algorithm that explores all the nodes at the present depth level before moving on to the nodes at the next depth level, ensuring the shortest path in unweighted graphs. Next, uniform cost search. Uniform cost search is also an uninformed search algorithm that expands the node with the lowest cumulative cost from the start node, ensuring that the least expensive path to the goal is found in weighted graphs. Next, what is depth first search? Depth first search is also uninformed search algorithm that explores as far down a branch of the search tree as possible before backtracking to explore other branches, often using a stacked data structure for implementation. Next, what is informed search strategies? Informed search strategies utilize heuristic information to guide the search process more efficiently towards the goal, often improving performance over uninformed methods by prioritizing paths that are estimated to be more promising. So, in this, first comes greedy best first search. Greedy best first search is an informed search algorithm that selects the node to expand based solely on the lowest estimated cost to reach the goal, as determined by a heuristic function without considering the cost to reach the current node. Next is A star search. It is also an informed search algorithm that combines the benefits of both uniform cost search and greedy best first search by using a cost function that considers both the actual cost to reach a node and a heuristic estimate of the cost to reach the goal, ensuring optimality and completeness. Next is heuristic functions. Heuristic functions are problem specific estimations that provide a measure of the cost or distance from a given state to the goal state, guiding search algorithms in making more informed decisions to improve efficiency and effectiveness. Now there is something called a search in complex environments. Searching in complex environment involves navigating through intricate and often dynamic spaces with numerous obstacles, uncertainties and varying conditions, requiring advanced algorithms and strategies to efficiently find optimal and satisfactory solutions. Now, what are optimal decisions in games? Optimal decision in games refers to the strategies or moves that maximize a player's chances of winning by considering the potential responses of opponents and the overall game dynamics, often determined through techniques like minimax algorithms or reinforcement learning. Now what is heuristic alpha beta search? Heuristic alpha beta search is an optimization technique for the minimax algorithm that reduces the number of nodes evaluated in the search tree by pruning branches that cannot possibly influence the final decision, thereby improving efficiency in two-player games. Next is Monte Carlo tree search. It is also a heuristic search algorithm that uses random sampling of the decision space to build a search tree and evaluate the potential outcomes of moves, making it particularly effective for complex games with large state spaces such as Go and chess. Next is adversarial search. Adversarial search. Adversarial search is a type of search algorithm used in game theory and artificial intelligence that involves finding optimal strategies in environments where multiple agents, that is players, compete against each other, often employing techniques like minimax and alpha beta pruning to evaluate possible moves and counter moves. Next, local search and optimization problems. Let us discuss about them. Local search is an optimization technique that iteratively explores neighboring solutions in a search space to find improved solutions, making it particularly useful for solving complex optimization problems where global search methods may be computationally expensive or infeasible. Next, what is local search in continuous spaces? Local search in continuous spaces involves exploring the solution landscape by iteratively moving to neighboring points based on gradient information or other heuristic or other heuristics to find local optima, making it suitable for optimization problems where solutions are represented as real valued vectors. Searching in non-deterministic actions. Searching with non-deterministic actions involves planning and decision making in environments where the outcomes of actions are uncertain, requiring algorithms to account for multiple possible future states and their associated probabilities to effectively navigate and optimize the search process. Now let us discuss knowledge, reasoning and planning. Knowledge, reasoning and planning are interconnected processes in artificial intelligence where knowledge represents the information about the world, reasoning involves drawing logical conclusions from that knowledge, and planning entails devising a sequence of actions to achieve specific goals based on the inferred information. Next, what is logic agents? Logic agents are intelligent systems that use formal logic to represent knowledge about the world, enabling them to make inferences, draw conclusions, and make decisions based on the knowledge to achieve their goals. Next is based agents. Based agents are intelligent systems that operate by utilizing a specific set of rules or models to interpret their environment, make decisions, and take actions based on the information they gather, often adapting their behavior according to the context and feedback received. Now, what is Wumpus world? Wumpus world is a classical artificial intelligence problem that simulates a grid-based environment where an agent must navigate to find gold while avoiding hazards like deadly wumpus and bottomless pits, using limited sensory information to make decisions. Now, first, what is logic? Logic is the systematic study of valid reasoning and inference, focusing on the principles and criteria that determine the validity of arguments and the relationships between propositions. Now, what is propositional logic? Propositional logic is a branch of logic that deals with propositions, which are declarative statements that can be either true or false, and uses logical connectives to form complex expressions and evaluate their truth values. Now, what is proposition theorem? Proposition theorem is the process of demonstrating the validity of a propositional logic statement or formula through a systematic method such as truth tables, natural deduction, or resolution to establish that it is logically entailed by a set of axioms or premises. Now let us see what is syntax and semantics of first order logic. The syntax of first order logic defines the formal structure and rules for constructing valid expressions using symbols, predicates, functions, and quantifiers, while the semantics provides the meaning of these expressions by interpreting them in terms of objects, relations, and truth values within a given domain. Now let us see how we use first order logic. Using first order logic involves expressing statements about objects and their relationships through quantifiers and predicates, allowing for rigorous reasoning and inference in mathematical and computational contexts. What is knowledge engineering in first order logic? Knowledge engineering in first order logic involves representing and organizing knowledge as a set of formal statements using predicates, functions, and quantifiers to capture complex relationships and rules, and reasoning about this knowledge to draw inferences and make decisions. Now, what is inference in first order logic? Inference in first order logic involves applying formal rules of deduction to a set of axioms and assumptions, allowing for the derivation of new statements that are logically entailed by the original ones, and enabling automated reasoning and decision making based on complex and nuanced knowledge representations. Now let us compare propositional inference versus first order inference. Propositional inference deals with reasoning about simple statements and their logical combinations, whereas first order inference extends this to reasoning about objects, properties, and relationships, allowing for more expressive and nuanced knowledge representation and reasoning. Now, what is unification and lifting? Unification and lifting are key operations in first order logic, where unification involves finding a common substitution for variables to make two expressions identical, and lifting involves generalizing a substitution to apply to a larger set of expressions, enabling efficient and effective reasoning and inference. Now, what is forward chaining? Forward chaining is a rule based inference strategy in which the system starts with a set of known facts and applies rules to derive new facts, iteratively adding to the knowledge base until no new facts can be inferred or a goal is reached. Now, what is backward chaining? Backward chaining is a goal driven inference method that starts with a specific goal and works backward through rules to determine which facts must be true to support that goal, effectively searching for evidence that confirms the desired conclusion. Now, what is resolution? Resolution is a rule based inference method that involves applying a set of rules to a knowledge base to derive facts by iteratively resolving contradictions between clauses, ultimately leading to a conclusion or refutation of a hypothesis. Next, let us see knowledge representation. Knowledge representation is the process of encoding and organizing knowledge in a way that allows it to be stored, retrieved, and manipulated by computers using various techniques such as semantic networks, frames, and ontologies. What is ontological engineering? Ontological engineering is a process of designing, building, and maintaining ontologies, which are formal representations of knowledge that provide a shared understanding of a domain to support knowledge sharing, reuse, and reasoning. Now, what are categories and objects? Categories and objects are fundamental concepts in knowledge representation, where categories, also known as classes or concepts, represent abstract groups or types, and objects, also known as instances or individuals, represent specific entities that belong to those categories. Now, what are events? Events are occurrences or happenings that take place at a specific point in time and space, often involving objects, agents, and actions, and can be represented in knowledge representation systems to capture dynamic and temporal aspects of knowledge. What are mental events and mental objects? Mental events and mental objects refer to internal subjective experiences such as thoughts, feelings, and perceptions, which can be represented in knowledge representation systems to model cognitive processes, emotions, and consciousness. Now, what are reasoning systems for categories? Reasoning systems for categories are frameworks or algorithms that enable the inference of relationships, properties, and hierarchies among different categories, allowing for the classification, generalization, and deduction of knowledge based on defined rules and logical structures. What is reasoning with default information? Reasoning with default information involves using formal systems and algorithms to draw inferences and make decisions based on incomplete or uncertain knowledge, where default assumptions or rules are applied to fill in gaps and provide a basis for reasoning. Now let us see definition of machine learning. Machine learning is a subfield of artificial intelligence that involves the development of algorithms and statistical models that enable computers to learn from data, make predictions, and improve their performance on a task without being explicitly programmed. Now, what are attributes? Attributes are characteristics, properties, or features that describe or define an object, concept, or entity, providing additional information about its nature, behavior, or relationships, and are often used in data modeling, classification, and reasoning systems. Now, what are categories of attributes? Attributes can be categorized into different types, including nominal, ordinal, interval, ratio, and binary attributes, which are classified based on their data type, measurement scale, and level of precision. Now, what is estimation of missing values classification? Estimation of missing values classification involves categorizing missing data into three types: MCAR, missing completely at random; MAR, missing at random; and MNAR, which means missing not at random, to determine the underlying mechanism of missingness and choose an appropriate imputation method. Now, what are types of machine learning? The main types of machine learning are supervised learning, where models are trained on labeled data; unsupervised learning, which involves finding patterns in unlabeled data; semi-supervised learning, which combines both labeled and unlabeled data; and reinforcement learning, where agents can learn to make decisions through trial and error in an environment. Now, what is classification? Classification is a type of supervised learning where a model is trained to predict a categorical label or class that an instance belongs to, based on its features or attributes, with the goal of assigning a new instance to one of the predefined classes. What is Naive Bayes? Naive Bayes is a family of probabilistic machine learning algorithms based on Bayes' theorem, which assumes independence between features and calculates the probability of a class given the features, to classify data into predefined categories. Now, what is a decision tree? A decision tree is a flowchart-like model used for classification and regression that splits data into subsets based on feature values, creating a tree structure where each internal node represents a decision based on an attribute. Each branch represents the outcome of the decision, and each leaf node represents a final class label or value. Now, what are classification trees? A classification tree is a type of decision tree that uses a recursive partitioning approach to classify data into predefined categories by splitting the data into subsets based on feature values, with the goal of predicting a categorical target variable. Now, what is pruning? Pruning is a technique used to reduce the complexity of a decision tree by removing branches or nodes that do not contribute significantly to the tree's predictive accuracy, thereby preventing overfitting and improving the model's generalizability. Now, what is rule extraction from tree? Rule extraction from a decision tree involves deriving a set of if-then rules from the tree structure, where each path from the root to a leaf node represents a specific rule that can be used for classification based on the conditions defined by the tree splits. Now, let us see what are supervised learning and unsupervised learning. Supervised learning involves training a model on labeled data to learn the relationships between input features and a target output, whereas unsupervised learning involves training a model on unlabeled data to discover patterns, relationships, or groupings within the data. What are ensemble methods? Ensemble methods combine the predictions of multiple Bayes models such as decision trees or neural networks to produce a more accurate and robust final prediction, often by reducing overfitting and improving generalization through techniques like bagging, boosting, or stacking. Now, what is bagging and what is random forest? Bagging or bootstrap aggregation is an ensemble method that involves the stability and accuracy of machine learning algorithms by training multiple decision trees on different subsets of the training data created through bootstrapping and then aggregating their predictions, with random forest being a popular implementation that uses this approach to enhance performance and reduce overfitting. What is boosting and gradient boosting and AdaBoost? Boosting is an ensemble method that iteratively trains multiple weak models, with each subsequent model attempting to correct the errors of the previous one. And popular implementations include gradient boosting, which uses gradient descent to minimize the loss function, and AdaBoost, which adaptively adjusts the weights of the training data to focus on misclassified instances. What is clustering? Clustering is an unsupervised machine learning technique that groups similar data points or observations into clusters based on their characteristics, patterns, or features, with the goal of identifying underlying structures, relationships, or distributions within the data. Now, what are clustering methods? Common clustering methods include hierarchical clustering, which builds a tree-like structure of clusters, k-means clustering, which partitions data into k distinct groups, dbScan, density-based spatial clustering of applications with noise, which groups data based on density and proximity, and k-medioids, which is a variant of k-means that uses medioids instead of centroids. Now, what is cluster analysis and requirements? Cluster analysis requires a data set with relevant features, a suitable distance or similarity measures, a chosen clustering algorithm, and a method for determining the optimal number of clusters, such as elbow method or Silhouette coefficient. Now, what are partitioning methods? In that also, what is k-means? K-means is a widely used partitioning method that divides the data into k distinct clusters by iteratively updating the centroids of the clusters and reassigning data points to the closest centroid until convergence or stopping criterion is reached. Now, what are k-medioids? K-medioids is also a partitioning method that is similar to k-means, but instead of using centroids, it uses medioids, which are actual data points that are representative of their cluster, making it more robust to outliers and noise. Now, what are hierarchical methods? Uh, in that also, let us discuss agglomerative and divisive hierarchical clustering. Agglomerative hierarchical clustering starts with individual data points and merges them into clusters, whereas divisive hierarchical clustering starts with the entire data sets and splits it into smaller clusters, with both methods producing a dendrogram to visualize the clustering hierarchy. Distance measures in algorithmic method. One of the distance measure in algorithmic method is Birch, which is balanced iterative reducing and clustering using hierarchies. It is an algorithmic method that uses the clustering feature tree and the Euclidean distance measure to efficiently cluster large datasets by grouping similar data points into subclusters. Now, what is Chameleon? Chameleon is a hierarchical clustering algorithm that uses a dynamic model to merge or split clusters based on their density and connectivity, allowing it to effectively handle clusters of varying densities and shapes. Let us discuss evaluation of clustering. The evaluation of clustering involves assessing the quality of the clusters using metrics such as Silhouette coefficient, uh, Kalinski-Harabas index, and Davis-Baldwin index, which measures the compactness, separation, and overall structure of the clusters. Let us see how we assess clustering tendency. Assessing clustering tendency involves using statistical tests and visual methods such as Hopkins statistic and visual inspection of scatter plots to determine whether a dataset exhibits a natural grouping or clustering technique. Determining the number of clusters. Determining the number of clusters involves using methods such as the elbow method, Silhouette analysis, and gap statistic, which help in identifying the optimal number of clusters that best represents the underlying structure of the data. Measuring clustering quality. Measuring clustering quality involves evaluating the coherence and separation of clusters using metrics such as within cluster sum of squares, Silhouette score, and external validation indices like adjusted rand index or normalized mutual information. Now let us see reinforcement learning. Reinforcement learning is a machine learning paradigm where an agent learns to make decisions by interacting with an environment that maximizes cumulative rewards through trial and error. Now, what are elements of reinforcement learning? That are agent, environment, reward. The core elements of reinforcement learning include the agent, which is the decision maker, the environment, the external world with which the agent interacts, and the reward, a feedback signal indicating the desirability of the agent's actions. Now, what are Markov processes? A Markov process is a mathematical system that undergoes transitions from one state to another, where the probability of transitioning to a new state depends only on the current state and not on any previous states. Now, what is Markov reward process? Markov reward process is a Markov process that involves a reward function which assigns a reward or penalty to each state or transition, allowing the process to evaluate the desirability of different states and transitions. Now, what is a Markov decision process? A Markov decision process is a mathematical framework that consists of states, the current situation, actions, the decisions made by the agent, rewards, the feedback received by the feedback received for taking actions, and a policy, a mapping from states to actions that guides the agent's decision making. What is dynamic programming? Dynamic programming is a method for solving complex problems by breaking them down into smaller subproblems, solving each subproblem only once, and storing the solutions to subproblems to avoid redundant computation and efficiently find the optimal solution. Now, what is policy evaluation and improvement? Policy evaluation and improvement are two key components of reinforcement learning, where policy evaluation estimates the value of a given policy, and policy improvement updates the policy to make better decisions based on the evaluated values, iteratively refining the policy towards optimality. What is value iteration and policy iteration? Value iteration and policy iteration are two dynamic programming algorithms used to solve Markov decision processes, where value iteration iteratively updates the value function to find the optimal policy, and policy iteration alternates between policy evaluation and policy improvement to converge to the optimal policy. Temporal difference learning and Q-learning. Temporal difference learning and Q-learning are model-free reinforcement learning algorithms that learn from experience by updating value estimates based on the difference between predicted and actual outcomes, with TD learning focusing on state values and Q-learning focusing on state action values. TD prediction, TDO and TDA. TD prediction, TDO and TD lambda are variants of temporal difference learning, where TD prediction estimates the expected return, TDO uses a single step look ahead, and TD lambda uses a weighted average of all n step returns to balance exploration and exploitation, with lambda controlling the trade-off. Q-learning. Q-learning is a model-free reinforcement learning algorithm that updates the action value function, Q function, based on the difference between the predicted and the actual outcomes. Using the Q-learning update rule, Q in SA will get from QSA plus lambda of R plus alpha of R plus lambda max Q of S dash A dash minus Q of SA to learn the optimal policy. Off policy control using Q-learning. Off policy control using Q-learning involves learning the optimal action value function, Q function, while following a behavior policy and then using the learned Q function to derive the optimal policy, often using the greedy policy pi of S is equal to R max of Q of S comma A. So this was about the important terms in artificial intelligence. We will discuss elaborately in about artificial intelligence in coming videos. Thank you.